Hello everyone. Today I will be presenting on a topic, a novel multitask learning approach for context-sensitive compound type identification in Sanskrit. I am Jivnesh Sandan from IIT Kanpur. This is a joint work with the co-authors from IIT Kanpur, Kharagpur and Mandi. What is compounding in Sanskrit? Compound is defined as a collection of one or more entities that act as a single meaningful entity. For example, Rama and Ishvara component, when they combine together, forms a compound called Rameshwara. Compounding is ubiquitous in Sanskrit, and alternatively it is also called as a noun compound interpretation. It also serves for achieving brevity in expressing thoughts in the language. What is Sanskrit compound type identification task? The process of decoding an implicit semantic relation between the components of a compound in Sanskrit. For example, mango and juice. These are the two components of the compound word mango juice, and task is to identify the relation between these two components. So it has been formulated into related but different ways. First one is the classification task. So in this scenario the label is malt made of, and next one is the paraphrasing, where the paraphrase is juice made from mango. So in this work, we use the first formulation that frames a task as a multi-class classification problem. Before moving forward, I would like to spend some time to explain the existing approaches for noun compound interpretation in the English. Earlier approach prior to deep learning era mostly focus on the machine learning based approaches. And recently in 2015, neural based approaches proposed where the components of two compounds with their feature pass to the neural classifier. And recent approach is the FrameNet based classification approach. Specifically for Sanskrit, in Sanskrit compound type identification, so earlier approach was rule based, where Panini's rules were used to build the approach. In 2016, Krishna proposed a hybrid approach by integrating rule-based approach with data-driven approach. And in 2019, the Sandhan, he explored whether the purely engineering approach can outperform the hybrid approach. So if you see in all these approaches, the crucial information, the context is missing. Why context-sensitive compound type identification? It often depends upon the context or the word knowledge about the entities involved. The implicit relation between the components can be decoded only with the help of available contextual information. For example, Rama and Ishvara, these are the two components, and there are 5 possibilities. There are 5 classes, 4 are the broad classes, Tatpurusha, Bahuri, Avyayi and Dvanda, these are the broad classes, and Karmadhara is the subclass of the Tatpurusha. So out of these 5, the first 3 are the potential correct classes. So which one, it completely depends on the context present. So it may cause suboptimal performance in the question answering and machine translation like task. For example, in Karmadhara, the meaning of this compound would be Lord who is pleasing, in Tatpurush Lord of Rama, in Bahuri one who God is Rama. Let me give another example. So Pitambaram is the word, and these are the 2 different contexts. So in first component, so the meaning of the word becomes the Lord Vishnu, the semantic label is Bahuri, and then next the meaning of the compound word becomes the yellow cloth, and it's the semantic type is the Tatpurush. So you see that same compound by different contexts, and that leads to the different class and also the different meaning. So recently there was upsurge in contextual models, and models such as Elmo and Burt proposed, but no attention has been given to the context to build a context dependent model for a compound type identification. This probably due to the compounding is not predominant phenomenon in the resource-rich language such as English, and probably due to lack of task-specific context-sensitive label data. Our contribution in this work as follows: we propose a novel architecture which is context-sensitive and multitask learning We showcased morphological tagging and dependency parsing are helpful for this task, and they also serve as a proxy for explainability. We achieved the 7.71 absolute gains compared to the current state of the art, and we also showcased the efficacy of our proposed approach for English and Marathi. Our code and database is publicly available at the GitHub link provided here. So our proposed approach is the multitask learning approach. There are three main components. The first one is the classification component, where the pair-wise classification has been done between the context word and the compound word. Next one is the dependency parsing component, and the third one is the morphological tagging. So dependency parsing, he proposed that compounding is the mostly syntactic. So we investigated this. In our empirical investigation, we found that this indeed helps, and morphological information has direct correlation with the semantic classes. So this also helped in our empirical investigation. So these are the two auxiliary tasks of our multitask learning architecture. This is our proposed architecture. Aham Pitambaram Namami is the input string, where Pitambaram is the compound word. For modeling purpose, we augment compound word at the last. We use multilingual encoder. Motivation behind using multilingual encoder is morphological richness of the language process the out of vocabulary problem, and low resource nature poses the problem of data scarcity. So here we have used the XLMR multilingual encoder, and in multitask learning architecture, the morphological tagging is a sequence labeling architecture, and dependency parsing is another auxiliary task, and classification has been done pairwise. So each word present in the context and the target compound word, this pair has been classified, and finally the maximum voting has been applied to all the pairs to get the final prediction of the model. So more details about the classification and the biofine attention that we have used you can find in our paper. Coming to the dataset section, so we have focused on the binary compounds, and for Sanskrit there are two versions of data in two levels of classification. One is the broad and another is a fine grain, and similarly we also had experiment in English and Marathi. For the auxiliary tasks, so code label were not present, so we have used the predicted labels as pseudo labels for our purpose. For Marathi, the dataset was not available, so we have annotated this data. For annotation, we also built the framework for annotation. So more details about the annotation decision you can find in our paper. Coming to the results section, we have used the macro level precision recall F1 score and micro level accuracy as the evaluation matrix. And baselines, there are two context agnostic baseline and multilingual contextual baselines and monolingual contextual baselines. As mentioned earlier, there are two experimental settings. One is the coarse label, 4 labels are there, and in fine grain total 15 labels are there. In each setting, again there are two settings. One is the without context and another is with context. In all the setting, our proposed model outperformed all the baseline competing baselines, except in without context setting, the hybrid model outperformed in the precision and F1 metric. And if you contrast between the broad and the fine grain improvement, so fine grain there is huge improvement in the fine grain classification. So this again highlights the efficacy of our proposed architecture. Coming to the analysis section, so we perform the ablation analysis, and we found that elimination of any component deteriorates the performance, and out of all the components, context is the most crucial component. we also perform the error analysis, and we contrast between the without context setting and with context setting. So we find that mostly the misclassification has gone to the most populated class called Tatpurus. So you see that in both the scenarios the misclassification has gone to the most populated class, and this is mainly due to the imbalanced nature of the data. But in context setting, so mostly there is improvement, so 15% reduction is there, and these confusions in the other classes, they are mostly due to the sometimes some subclasses they share the first component, so that's why model get confused. But although the overall trend is same, but in the contextual setting we see the consistent improvement. In our multilingual experiment, we perform our analysis on the English and the Marathi dataset. In both the dataset, our model outperformed the existing baseline. But interestingly, in Marathi, with context, could not outperform the without context setting, and this is mainly due to data scarcity. And in Marathi, we could not activate the auxiliary task. Also, we performed the zero sort experiment and a multilingual experiment. We found that multilingual training helps for Marathi to improve the overall improvements. Coming to the probing analysis, blue attention heat map are for the classification attention, and the violet attention heat map are for the dependency parsing. Motivation behind the probing analysis that how do different contextual words contribute, and do these attention serve as proxy for explainability. So we found that Sakti attention, all the words mostly focus on the target word, and as per the grammatical rules, morphological tagging task correctly predicts the classes. And here especially if you see that in first setting the compound word is focusing in Namami, and in second setting the Pitambaram is correctly pointing out to the Vastram as per their meaning. Coming to the conclusion, so we focus on the context sensitive compound time identification. Existing approaches did not consider the context, which is very crucial, and in our architecture we consider morphological tagging and dependency parsing as auxiliary tasks along with the context. Auxiliary tasks also serve as a proxy for the explainability, and we found a stunning improvements with 7.7 points absolute gain compared to the current state of the art. Our multilingual experiment also shows the efficacy for Marathi and English. Our code and data sets are publicly available on the GitHub link provided. And in our future work, we will be planning to extend this by augmenting the logical rules derived from the Panini grammar. Thank you very much. I am open for the questions or any comments.